So I told you there were only 4 mechanisms that you needed to know. But these 4 mechanisms can be combined to make a lot of different reactions occur. So we look here, this is a proton transfer. This proton right here is being taken away from the bromine and it's going to appear over here. Loss of a leaving group. This whole hydroxy, this whole thing is leaving, and that leaves a carbocation here that's secondary. Secondary carbocations are less stable than tertiary carbocations, so we'll get a methyl rearrangement, and this methyl group, which we'll do in blue, will come up here. Giving us a tertiary carbocation that just rearranged. And then we end up with a nucleophilic attack. The bromine will attack, and the electrons that are here will make this bond between that carbon and that bromine. Note, all the arrows begin on a source of electrons. They begin on a bond or on a lone pair, and they end at an electrophilic or a positive charge. Okay, that will always occur. Okay, so I color-coded some of this already. We're supposed to read the arrows and identify the sequence. It's a good time for you to stop the video and look at this before I go through it. All right, so here we have electrons, and we see the electrons are being pulled from this pi bond to the sulfur. So that looks like a nucleophilic attack. These electrons right here are making this bond. So that's a nucleophilic attack. In this diagram, we see that this blue hydrogen is being transferred. We have hydrogen on this figure. This figure has no hydrogen, so the hydrogen's been removed. So this is a proton transfer. And then we have another proton transfer. This group has no hydrogen, but the product here has the hydrogen. It has this blue hydrogen. So this oxygen, these lone pairs right here, have attacked this proton, and we have proton transfer. All right. Then let's pull this up and look at this next one. Here we have a proton, and if we look at the next figure, that proton is gone, and so we have proton transfer. This blue hydrogen is here. Here it's missing, it's on this oxygen. Here we have an arrow. Its base is on these 2 electrons, and it's attracted to this nucleophilic, to this electrophilic center, and so this is a nucleophilic attack. Okay. Here we've got a group that's being forced out. These electrons that are green are going to end up on this oxygen. They end up being one of these lone pairs of our product. So this is a loss of a leaving group. The OR is our leaving group, and that's what left. Okay, when we draw curved arrows, we always place the tail on a bond or a lone pair. The head must either be at the formation of a bond or the formation of a lone pair. Do not violate the octet rule. Sometimes we have to draw another arrow to not violate the octet rule. So example, we have these 2 electrons are attacking this carbon. This carbon has 4 bonds, but because the oxygen can take 2 of its electrons back, that bond can happen. That happens. Okay. So let's draw the curved arrows that accomplish each of these transformations. First, let's draw in our lone pairs. And what's going to happen here is these lone pairs are going to come here and attack that electrophilic center. And they're going to make this bond right here. So let's look at the differences, going on to the next one, the difference between this and this. It's really just a hydrogen. So we have a proton transfer. We have lone pairs here. They're going to attack that proton. These electrons are going to end up on the oxygen. So these electrons are blue. They're going to end up right here. And make the hydrogen green. The hydrogen ends up here. And the pink, these pink electrons make this pink bond. And that's a proton transfer. Okay. This one, we need to figure out what's happened here. It looks to me like this bond here has been severed. This bond is no longer there. So what's happened here is that, I'm going to change colors just to make it clear. These electrons have ended up on that oxygen. And so they're right there. So this is loss of a leaving group.